I'm going to say just a bit about how you can use a chart and a deck compass to quickly find distances and compass directions on the water. If you do an expedition in someplace like coastal Alaska, you'll need additional navigation skills. Say you're on the bay and you think, here I am at Angel Island, the day is young and I'm frisky. How far is it to Red Rock? If you have a chart on your deck, you can use the scale in your knuckle joint to make a quick estimate. Or say you're out on the bay and fog rolls in. If you have a chart and a deck compass, you won't get lost. Of course, you can do these same things with a phone or a GPS. A chart and a compass don't need batteries, and sometimes they're quicker. Okay, distances. I already pointed out the scale on the chart. In addition, if your chart has north, south, and east-west grid lines, the spacing between successive east-west grid lines is equal to 1 nautical mile or some multiple of nautical miles. The homework has an illustration that explains how this works. The homework also has an exercise that asks you to figure out why this is only true for the spacing between the east-west grid lines and not for the spacing between north-south grid lines. Okay, direction. The grid lines already give you basic directional information since they're oriented north-south and east-west. For more detailed information, we use the compass rose, which should appear on any printed chart. Electronic charts that you use on a device don't need them and generally don't have them. The outer ring of the compass rose is straightforward. North points to true north, which is the North Pole that the Earth rotates around. The inner ring gives magnetic direction, with north pointing in the direction that a compass needle points at the location on Earth represented by the chart. You probably know that the Earth's magnetic poles wander around. This image from the ESA shows how the North Magnetic Pole has moved since 1840. Currently, it's out in the middle of the Arctic Ocean, trekking toward Russia at about 50 kilometers per year. The result for us is that right now in the Bay Area, magnetic north points about 13 degrees east of true north. The difference between true and magnetic north at a particular location is called the magnetic variation or magnetic declination. And I'll leave it to the homework to explain the information in the middle of the compass rose.